In this video, we are going to sketch a graph of this polynomial that's in factored form. So let's start with the x-intercepts. If I have a factor of x plus 3, that means I'm going to have an x-intercept, or a 0, of negative 3. So I know I'm going to have an x-intercept here at negative 3. Notice you do not distribute the negative sign or anything like that. You just leave it out there and don't do anything with it until later. Now this factor of x minus 1, that's going to give us a 0 root x-intercept of positive 1. So I'm going to have a x-intercept at positive 1, and we'll have one at negative 3. Now, we need to look at a chart such as this one and pay attention to the behavior of the graph at the x-intercept, because that's going to depend on the multiplicity of the factor. If it's a single factor, the graph just passes straight through like this. If it's a double factor, then you're going to have a bounce off of the x-intercept like that. If it's a triple factor, then we are going to have what is called an inflection. That looks like this. It's where the graph sort of flattens out as it passes through the x-intercept and then curves back and continues on. So we have to keep that in mind. Okay, so in these cases, at the negative 3, I am going to have a bounce, because this is squared, and that's when you have a bounce. At the x-intercept of positive 1, that's just going to go straight through. Because that has no exponent, so that's what it looks like when it just goes straight through. Okay, so there's one more piece of information that we need. Right now, we don't know whether we should be starting our drawing from up high and doing our bouncing through, or, because that would look like this, from up high, I could go bounce and I could go through, so maybe it might look like that. On the other hand, what if I started from down low? Then I could go bounce like that and then go through like that. It's completely upside down. So the way you know which one of those it is we have to think about end behavior. End behavior. Pay attention to the degree of this. Now, there are 2 of these factors and 1 of these. So the degree is 3. Okay, that is odd. Odd degree. Alright, 2 of these, 1 of these, that's 3, that's odd. Why do I keep saying that over and over again? Well, the degree being even or odd tells us whether the end behavior is going to look like this or whether the end behavior is going to look like this. If the degree is even, then both arms point in the same direction, either both arms up or both arms down. Alright, this is the positive version, this is the negative version. But we already know that the degree is odd. That means the end behavior is going to be like one of these 2 graphs. Alright, it's just a matter of which one. Alright, the positive version looks like a capital letter N. The negative version is sort of like a backwards capital letter N. So how do I know which one of these? It's going to be one of these because it's odd. Well, here's how I know. Right here in the front, I see this negative sign. Alright, that means we need the negative version. Alright, that means we need this version down here. Alright, the one that looks like a backwards N, starting high, ending low. Alright, so I'm just going to recopy that over here. So our end behavior is this type of end behavior, because it's odd and negative leading coefficient. End behavior goes from high to low. So now I know that I need to start high. Okay, and I will do my bounce and my through from up high like this. So if I start high, and here I go, I'm going to do my bounce and then through. So my graph should look something like this. Okay, now let's look at the multiple choice options. But we're looking something that goes from high on the left and then low on the right. So that's not A, and that's not D. We can eliminate those. Okay, now B and C both go from high to low. Now we need the one that bounces at -3 and goes through +1. Okay, bounces at -3, goes through +1. Looks like the answer is B. Yeah, this one bounces at -1 and goes through +3. So that's not going to be it. Okay, so the answer is B.